According to the National Electrical Code and other electrical codes, equipment and skid should be grounded to ensure the safety of personnel and equipment. NEC Article 250.4a states that electrical systems supplied from a transformer with a grounded secondary shall have the following conductively connected to the grounding electrode system: A. Grounding electrode conductor on the supply side of the service disconnect. NEC Article 250.32b specifies that exposed non-current carrying metal parts of equipment, raceways, and other enclosures shall be grounded. NFPA 70B recommended practice for electrical equipment maintenance recommends grounding all electrically powered equipment, including compressors and blowers. There are several benefits of proper grounding. Firstly, it protects personnel. Grounding provides a path for fault currents to travel safely to the ground, preventing electrical shock to personnel. Secondly, it prevents damage to equipment. Grounding reduces the potential for damage to equipment due to lightning strikes, power surges, or other electrical faults. Thirdly, it ensures reliable operation. Proper grounding helps protect sensitive electronics, such as variable frequency drives, from damage caused by electrical noise and other disturbances. There are specific methods of grounding. For equipment to skid, grounding strap should be used to connect the motor casing to the metal skid. For skid to ground, the skid should be connected to a grounding grid or, if a grid is not available, to a grounding rod. Grounding through the incoming power service is only acceptable if the power distribution system has a properly installed and maintained grounding electrode system. There are additional considerations. Grounding alone is not sufficient for lightning protection. Surge protection devices or lightning protection systems should also be installed. Grounding systems should be inspected regularly to ensure they are intact and functioning properly. Given the potential risks and NEC requirements, it is recommended that you request documentation of how the equipment is grounded in accordance with applicable codes. It is also prudent to consult with a qualified electrician to verify the adequacy of the existing grounding system. Grounding is a critical safety measure in electrical systems, and its purpose is to provide a low impedance path for fault currents to flow back to the source, thereby tripping over current protection devices like circuit breakers or fuses. This prevents dangerous voltage buildup on equipment enclosures, which could pose a shock hazard to personnel. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding to ensure electrical safety. Article 250 within the NEC is the primary source for grounding and bonding guidelines. The grounding electrode system is a network of interconnected grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes, that are bonded together to provide a common ground reference. The grounding electrode conductor connects the grounding electrode system to the electrical system's grounded conductor, typically the neutral, at the service entrance. Equipment grounding conductors provide a path for fault currents from equipment enclosures back to the source. These conductors can be wires, raceways, or other approved metal pathways. Bonding is the process of connecting metallic parts of electrical equipment and enclosures to create a continuous electrical path. This helps to equalize the potential between different metal parts, reducing the risk of shock. The size of grounding conductors is determined by the size of the overcurrent protection device protecting the circuit. NEC Table 250.122 provides guidance on sizing equipment grounding conductors. Ground rods should be at least 8 feet long and driven into the ground until at least 8 feet of their length is in contact with the soil. The spacing between ground rods should be at least equal to their length. When using a metallic water pipe as a grounding electrode, it must be supplemented by another grounding electrode, such as a ground rod or ground plate. Grounding and bonding are essential for protecting sensitive electronic equipment from damage due to voltage surges and electrical noise. Proper grounding and bonding can improve the reliability and performance of electrical systems. Regular inspection and testing of grounding systems are necessary to ensure they are functioning properly. A ground resistance tester can be used to measure the resistance of the grounding electrode system. High resistance indicates a problem with the grounding system that needs to be addressed. When working on electrical equipment, always verify that the equipment is properly grounded before starting work. Use a multimeter to check the continuity between the equipment enclosure and the grounding electrode system. If the equipment is not properly grounded, do not proceed with the work until the grounding issue is resolved. Grounding requirements vary depending on the type of electrical system and the application. Consult the NEC and other applicable electrical codes for specific grounding requirements. Variable frequency drives, or VFDs, are used to control the speed of electric motors. VFD can generate harmonic currents that can interfere with other electrical equipment. Proper grounding and bonding are essential for minimizing the effects of harmonic currents. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning strikes or other events. SPD should be installed at the service entrance and at sensitive electronic equipment. Lightning protection systems are designed to protect buildings and structures from lightning strikes. Lightning protection systems include air terminals, down conductors, and grounding electrodes. Grounding is not a substitute for lightning protection. Lightning protection systems are designed to provide a safe path for lightning currents to flow to ground, minimizing the risk of damage or injury. Electrically powered equipment, such as compressors and blowers, should be grounded in accordance with NFPA 70B, recommended practice for electrical equipment maintenance. NFPA 70B provides guidance on the maintenance and testing of electrical equipment. Grounding systems should be inspected regularly to ensure they are intact and functioning properly. The resistance of the grounding electrode system should be measured periodically to ensure it is within acceptable limits. Any damaged or corroded grounding component should be replaced immediately. The grounding system should be tested after any modifications or repairs are made to the electrical system. Proper grounding is essential for the safety of personnel and the reliable operation of electrical equipment. By following the grounding requirements in the NEC and other applicable electrical codes, you can minimize the risk of electrical shock, equipment damage, and other hazards. The installation contractor's assertion that the equipment is grounded through the incoming power service may not be sufficient to meet all applicable code requirements. The NEC requires that equipment enclosures be grounded to provide a low impedance path for fault currents. This grounding path should be independent of the grounding provided by the power service. The variable frequency drive's occasional damage when lightning is in the area is a strong indication that the grounding system is inadequate. Lightning strikes can generate very high voltage surges that can damage sensitive electronic equipment. Proper grounding and surge protection are essential for protecting VFD from lightning strikes. Consulting with a qualified electrician is crucial to assess the existing grounding system and recommend any necessary upgrades or repairs. The electrician can verify that the grounding system meets all applicable code requirements and that it is adequate to protect the equipment from electrical hazards. Grounding is not a one-size-fits-all solution. The specific grounding requirements for a particular installation will depend on the type of equipment, the voltage level, and the environmental conditions. The NEC provides detailed guidance on grounding requirements for various types of electrical systems and equipment. It is important to carefully review the NEC and other applicable electrical codes to ensure that the grounding system is properly designed and installed. Grounding is an essential part of any electrical safety program. By implementing a comprehensive grounding program, you can protect personnel, prevent equipment damage, and ensure the reliable operation of electrical systems. Regular training on grounding principles and practices is essential for all electrical workers. Electrical workers should be familiar with the NEC grounding requirements and the proper procedures for grounding electrical equipment. A well-designed and maintained grounding system is a valuable investment that can save lives and protect property. Grounding is not just a code requirement, it is a fundamental safety principle that should be followed in all electrical installations. Over the life of an electrical installation, the grounding system will degrade. It is thus important to maintain the grounding system by testing and visual inspection. The resistance of ground rods will increase over time, and the connections will corrode if not maintained properly. The cost of maintaining a grounding system is minimal as compared to the cost of equipment damage, downtime, or potential injury or death. Grounding and bonding are often used together, and it is important to understand the difference between the two concepts. Grounding provides a path for fault currents to flow back to the source, while bonding connects metallic parts of electrical equipment and enclosures to create a continuous electrical path. Both grounding and bonding are essential for electrical safety. The NEC requires that all metallic parts of electrical equipment and enclosures be bonded together to create a continuous electrical path. This helps to equalize the potential between different metal parts, reducing the risk of shock. Bonding conductors should be sized according to NEC Table 250.102. Bonding conductors should be installed in a manner that minimizes the impedance of the bonding path. The grounding system should be designed to minimize the risk of ground loops. Ground loops can occur when there are multiple grounding paths, which can create unwanted currents in the grounding system. Ground loops can cause interference with sensitive electronic equipment. The grounding system should be designed to minimize the effects of lightning strikes. Lightning strikes can generate very high voltage surges that can damage electrical equipment. Surge protection devices should be installed to protect sensitive electronic equipment from lightning strikes. The grounding system should be designed to minimize the risk of static electricity buildup. Static electricity can build up on equipment enclosures, which can create a shock hazard. Static electricity can also damage sensitive electronic equipment. Anti-static mats and wrist straps should be used when working on sensitive electronic equipment. The grounding system should be designed to minimize the risk of electromagnetic interference, or EMI. EMI can interfere with the operation of sensitive electronic equipment. Shielded cables and enclosures should be used to minimize the effects of EMI. The grounding system should be designed to comply with all applicable codes and standards. The NEC is the primary code for electrical installations in the United States. Other codes and standards may also apply depending on the type of electrical system and the location of the installation. It is important to consult with a qualified electrician to ensure that the grounding system complies with all applicable codes and standards. A well-designed and maintained grounding system is an essential part of any electrical safety program. By following the grounding requirements in the NEC and other applicable electrical codes, you can minimize the risk of electrical shock, equipment damage, and other hazards. Remember to use grounding straps to connect the motor casing to the metal skid. Then, connect the skid to a grounding grid or grounding rod. Grounding through the incoming power service might not be enough. Consider lightning protection measures beyond grounding, like surge protection devices. Inspect your grounding systems regularly to keep them in good shape. And remember, when in doubt, get a qualified electrician to check things out. Grounding is not just about meeting code, it is about protecting people and equipment.